I will try to describe how to get the bar force in a 3-bar truss. And obviously there's a lot of different ways of doing it. The first question that you have to address is, should I just make a truss where I know the 3 points? Or should I make a truss where I know the 3 sticks? And you can't do both. You have to do one or the other because the sticks lengths are not arbitrary. So let's suppose for this example, just to keep things quick, that we will put these sticks down and it doesn't matter where I put them. So I'm just going to fix these right now just so that I will never move these accidentally, which happens all the time. And then I'll just make some sticks between here and just call that the original. Alright, so now let me turn this off, which I can't do without doing this trick, and zoom in. Okay, so now those, I'm going to call that stick 1, stick 2, just so I don't forget, and stick 3. Before I forget, the other thing, I think you should just call this the pin, call this the roller. Don't worry about the green triangle, the green circle. Those will confuse you later. Now, if you're looking for the reaction, you can just get the rigid polygon, but we don't want that right now. So let's say we wanted stick 2. So what I suggest is putting in a slider. I don't use sliders for a lot of things, but for this example, I think it would be kind of nice. It doesn't matter. Okay. And now here's the tricky part. So I need to find the new shape where stick 2 perhaps is elongated. So let's do the circle with center and radius. And don't click on this point here, which locks it into that point. Call it stick 1. I saw you do that yesterday. Now, and this is our new truss. It starts here. Now the second circle is going to be stick 2 plus delta. I thought I called that delta. Okay, so the second circle will be stick 2 plus delta. Stick 2 plus delta. All right, and now I need to make a decision. I need to intersect this stick with stick 3, that circle. Not with this circle, but with the stick 3 circle. Because stick 1 and stick 2 do not change lengths. The only stick that changes length is the one being stretched. So let's find the intersection of this and that. And now we should have this and this. Let me show the values on these. Oops. Okay. Oh gosh. All right. Stick 1. Sorry. Let me make them all object properties. Just let me show the value. I don't need. All right. So what was 6.87 is 6.87. What was 6.5 is 6.5, and the delta is let's say it's 1. So then I had 5.99 originally and 6.99 originally. So this is what you have to do, but obviously this error is, let's call that roller prime. I like using the prime, it's just so fast. So the error is y of roller prime minus y of roller. Okay, now you could put in a segment, which I think you should, just as a visual. So I do the perpendiculars like that, and then the intersection. It's a nice visual, but you could also you still have to program that thing. You could use the caption, for instance, here, since you've already used the word error, and you could just call that error. So just as a caption. And then the nice thing about this is that we could visually see the error getting smaller, and the error has to be 0 for any delta. So notice that the error and the delta are two different things, right? So this is very important. So given a delta, you bring the error down to 0, and I like to have things just slightly positive. Just slightly positive, so you can see my error is 0.03. And then everything seems to work just fine. And then obviously the lofts here are going to be for a vertical load. The loft is the horizontal distance. Here again, you might consider just putting in the segments, because they're super nice visually anyway. So I would suggest doing something like that. The way I just do it is I drop a point here, I make a perpendicular line, and I get the intersection there. And then I call that loft X, for instance. And this would be, rename that as loft X, or, it doesn't matter, or loft horizontal or whatever. And it looks nice even for printing purposes, like, if you were to print this up as a, and then the loft Y would obviously be the vertical distance between these. So I think the biggest question is, how do you set it up? Do you set it up in terms of sticks, or do you set it up in terms of three-dimensional coordinates? And I think as you're starting, the three-dimensional coordinates are easier, but for the board game, you need the stick lengths. So for the board lengths, you only have the sticks, and you have to build this thing out of the given sticks, and that's the way we do engineering anyway. We can predict where this point is in three-dimensional space for a 3D structure, but we bring the real sticks to the site. Okay, hopefully that'll help you. Let's talk soon.